Good morning, everyone, and welcome to another session of the Q&A webinar with Big Switch Networks. My name is Sharon Fitzpatrick, and I'll be your host for today's webinar, Red Hat and Big Switch Integrated OpenStack Solutions for Simplified Cloud Deployment. We'll get started here in a minute, but before we do that, and I introduce the topic and the co-host for today, let me quickly go over some of the housekeeping information. We host this webinar twice per month, Wednesdays at 10 a.m. Pacific Time, 1 p.m. Eastern, and a bit later in the day for our European and Asian audiences. We have structured it as a 30-minute Q&A session. We typically start off by going over a few slides to provide context and an overview of a particular topic, and spend the second half of the session doing a live product demo. As we go through the presentation, I encourage you to ask questions using the Q&A box on your webinar dashboard. If you are watching this video in a rebroadcast or a recording, or if you have questions on a particular upcoming webinar topic that you'd like our panelists to address, I highly recommend that you go to bigswitch.com/webinars and submit a question using the link provided. Finally, at Big Switch, we believe that there is no better way to learn about a product or technology than to actually take it for a test drive. For free online real-time access to our SDN Fabric products, please visit lab.bigswitch.com. Big Switch Networks and Red Hat have collaborated to fully integrate Big Cloud Fabric with the Red Hat Enterprise Linux OpenStack Platform 7, or RHEL OSP 7, providing a simplified and scalable OpenStack networking solution for enterprise and service provider infrastructure teams. At this time, what I'd like to do is introduce today's panel. Glenn Rudolph, the Global Business Development Director for Red Hat, Bala Ramchandran, the Director for Product Management at Big Switch Networks, and Ganapati Bhatt, the Senior Technical Marketing Engineer from Big Switch Networks.
Thank you, Sharon. Good morning, everyone. So today, we'll be discussing the solution that Red Hat and Big Switch have jointly collaborated on to solve a key customer use case, which is OpenStack Telco Cloud for NFV workloads. There are several unique characteristics of the joint solution that makes it unique for such deployments. Characteristics such as resilience at scale, no bandwidth bottlenecks, logical network design, and reduced operational complexity. So we'll start the webinar today by discussing the details of this fully integrated solution, its unique value proposition, details of the solution components, and finally end with a demo of the solution. So the joint solution consists of Red Hat OpenStack Platform 7 fully integrated with Big Cloud Fabric, as Sharon talked about. So let me start off here with a brief overview of Big Cloud Fabric, the industry's first SDN-based data center fabric built with open networking switches. So it's a modern leaf-spine class SDN fabric providing physical and virtual workload connectivity within a data center pod. So this class fabric design is optimized for extreme east-west as well as north-south bandwidth requirements, which is typical for telco environments. So to the left of this picture, you see the Big Cloud Fabric controller, where fabric configuration, automation, and troubleshooting can be achieved through a single pane of glass, offering tremendous operational simplicity. While most of the fabric intelligence is in the controller, some of it is judiciously offloaded to a switch-lite OS, a thin OS which runs on each switch in the fabric. So this offloading essentially enables the resiliency and scale of the fabric. So the Big Cloud Fabric controller also acts as a single point of integration with OpenStack cloud orchestration systems such as the Red Hat OpenStack platform. There are two key aspects of this integration that we will talk about. The integration of installers from both vendors and network automation which is achieved through this integration. Next, the leaf and spine switches in the fabric are dense 10 gig, 40 gig bright box or white box switches that we support from vendors such as Dell or Acton. The resilience aspect that I talked about is achieved as something which is built in throughout the fabric across all switches, not just at the controllers, thus ensuring no single point of failure. Leveraging open networking hardware with our SDN software helps us deliver a very cost-effective production-grade solution, a solution that is delivered as a complete integrated package with a single point of support. BCF makes deploying applications really simple with configuration based on tenant-centric logical networks, and it helps achieve application agility with seamless insertion of layer 4 to layer 7 services. So next, let's talk about the joint solution itself. The joint solution really combines OpenStack with software-defined networking to remove complexity altogether while enabling flexibility, openness, and automation to essentially build a self-service cloud environment. So the first aspect of the integration is the fully integrated installer workflow. So with this solution, the BCF OpenStack installation steps are completely integrated into the RHEL OSP 7 director installer workflow. So some of the key steps involved here are the installation of the BSN ML2 plugin, enabling LLDP on compute nodes, which then enables automatic lag creation. The second aspect of the integration is the network automation. BCF is integrated with OpenStack Neutron via the BSN ML2 plugin, which is installed on the OpenStack controller nodes during the installation. So with this plugin installed, the Neutron service invokes the BCF controller through the REST APIs to dynamically provision tenants and VLANs on BCF physical network, as the networks are configured by OpenStack tenants. So the joint solution essentially simplifies OpenStack networking and the overall deployment, which will help you improve operational efficiency, increase uptime, reduce costs, and boost scalability. So finally, a quick summary of the key solution benefits. Firstly, simplicity. So as we discussed earlier, the fully integrated installer process achieved by the solution tremendously simplifies OpenStack deployments. This also ensures that the upgrade processes are majorly simplified. This, combined with the major operational simplification that is core to BCF's value proposition because of the fabric automation, the end-to-end visibility, and ease of troubleshooting, makes the solution very compelling for production-grade OpenStack clouds. The second aspect is agility. The application-centric multi-tenant architecture of BCF enables each tenant to have administrative control over logical layer 2, layer 3, and policy design. Within this multi-tenant infrastructure, tenant-managed service chains with LBAS and firewall, provider-managed service chains transparent to the tenants can be provisioned seamlessly to enable agility in application deployment. And finally, the economics of the solution. We talked about how the model of disaggregation of hardware from software provides great flexibility and avoids vendor lock-in, thus offering a dramatic cost advantage. According to a recent ACG research study on BCF, where they compared BCF with the current mode of network operations, combining the CapEx reduction which is achieved with BCF along with the operational benefits that can be realized, the solution offers over 50% TCO reduction to our customers. I'd now like to turn it over to Glenn, who will talk in detail about the RHEL OSP 7 design and workflows and how it can be leveraged in SDN environments for simplified OpenStack deployment.
Thanks, Bala. So our RHEL OSP 7 release is based on the upstream OpenStack Kilo that we have a 3-year life cycle service associated with it. And it's integrated with Red Hat Enterprise Linux 7 as the host operating system. There are many new features in OSP 7 that I can talk about, like compute with I/O-based NUMA scheduling or CPU pinning or huge pages. I can talk about storage, incremental backup, private volume types, enhanced iSCSI multipath support. I can even talk about identity, all the new features associated with hierarchical multi-tenancy, federation support. There's so many areas of RHEL OSP 7 we could talk about, but today we're going to focus on RHEL OSP 7 Director and neutron networking. So new in RHEL OpenStack Platform 7 is our Director, which is a combination of the best installer tools integrated with a community OOO management project. So it brings together the best installation mechanisms from SpinalStack, which is an acquisition from when we acquired Enobonce, Foreman from RHEL OSP 6 installer, and now OOO, all built on a robust API backend. It's designed to not only provide a production-ready installation, but also eases the complexity of daily operations and ongoing management. It provides a simplified, policy-driven means of resource monitoring and orchestration to help cloud operators focus more on delivering business value than having to manage system resources. So let's take a quick look at the big picture. The RHEL OpenStack Platform Director provides deployment consistency in your data center. Leveraging the integration automation tools, it consistently deploys a production-ready environment that is automatically health checked during both installation and after. This check also helps to identify any errors or potential misconfigurations, ensuring long-term scalability. The Director also offers integrated lifecycle management over the entire cloud infrastructure. This is a key factor in easy day-to-day resource management. It also provides integrated system monitoring with status and error alerts. This helps to ensure proper node function and behavior and takes necessary actions in the event of a failure. So we now introduce a new concept, the overcloud and the undercloud. The overcloud is the OpenStack that we all know and love, right? Nova, Glance, Swift, Cinder, Neutron, and all the rest of its components. What's new is the undercloud. It's based on our new Director, which is responsible for the deployment and management of our OpenStack platform. So let me quickly take you through a graphical depiction of exactly what I'm talking about. First, what's our goal? Well, we want to achieve an operational cloud. How do we do that? You install Director on one or more management nodes, which you see here. You then use your interface of choice to configure the infrastructure, whether it's command line or using the graphical interface or an API. After that, the Director then examines your hardware associated with your infrastructure using Ironic. Once that is completed, you define the controller nodes. And then the resource nodes. And the controller and resource nodes now get provisioned. You can see there my OpenStack deployment. And now, lo and behold, you have all the required elements associated with the RHEL OSP Director Undercloud and the RHEL OSP 7 Overcloud. So, to sum it up, our new RHEL OpenStack Platform Director facilitates planning, deployments, and ongoing operations of RHEL OpenStack infrastructure.
Hey Glenn, hey, thank you so much. That was very useful and a great overview of the workflow of the director. But can you talk about how Big Switch installer gets incorporated into this workflow and how that benefits our customers?
Yeah, actually, that's a good question. This is what we've been working on Red Hat and Big Switch over the past several months. So what we've accomplished with Big Switch Networks is now the Big Switch Fabric installer is integrated into our RHEL OpenStack Platform 7 director. So you don't need a separate installer to get the functionality of the Big Switch Fabric. What happens is our mutual customers can now enjoy a fully integrated solution for OpenStack deployments. It's really simplified, right? And the overall OpenStack experience is fully enjoyed. So now, let me turn it back over to Big Switch to demonstrate what Bala and I have just discussed.
Welcome to the video demonstration of Big Cloud Fabric integration with Red Hat Enterprise Linux OpenStack platform RHEL OSP 7. In this demo, I'll be demonstrating two aspects of the Red Hat OpenStack deployment with Big Cloud Fabric. First, I would show how RHEL OSP under cloud streamlines the deployment of reliable and scalable OpenStack cluster. Secondly, I will show OpenStack tenant workflow for application deployment and show how dynamic provisioning is done on fully integrated Big Cloud Fabric with Red Hat OpenStack platform from data path perspective. Let's look at the Red Hat Enterprise Linux OpenStack platform basic layout. The Red Hat Enterprise Linux OpenStack platform uses two main concepts, an under cloud and an over cloud. The under cloud is a tool set for installing and managing the over cloud. The over cloud is the resulting Red Hat Enterprise Linux OpenStack platform environment created using the under cloud, which includes the OpenStack controllers, compute nodes, and storage nodes. For today's demo, I'll be using following Big Cloud Fabric physical topology, which has 9 racks with 36 physical servers connected to the Big Cloud Fabric. And I have deployed over cloud on these servers. This is the under cloud director node command line interface. The over cloud is deployed using following command with different set of options. The over cloud in this example consists of 3 OpenStack controllers and 33 compute nodes for tenant workload deployment. Red Hat Ceph Storage is the option here to provide the storage virtualization layer for the deployed over cloud. The Big Cloud Fabric is fully integrated with Red Hat OpenStack Platform 7. To enable the full integration, use Big Switch Neutron ML to YAML file as the additional environment to the over cloud deployment command. The default Big Switch Neutron ML2 file need to be updated with the IP address and the credential of the Big Cloud Fabric controller for the given setup. Once you run this command, it deploys the overcloud as per the planned environment. I'm not going to run overcloud deployment now, as it takes few minutes to complete. However, I will show the deployed overcloud environment. Issue the command nova list on the undercloud directed node. It would show all the installed overcloud nodes. In this case, we have 3 OpenStack controller nodes and 33 compute nodes. This is the overcloud OpenStack Horizon dashboard. Let's log in as admin. As you see, this OpenStack cluster has 3 controller nodes and 33 compute nodes. All these overcloud nodes are connected to the Big Cloud Fabric. BCF controller does host auto discovery, that is, BCF auto detects all the overcloud nodes using LLDP and forms the LACP based link aggregation. There is no manual configuration required on Big Cloud Fabric to do this. You can expand each of these link aggregation to get more details on the switch and the interface where it is connected. That is how Red Hat OpenStack platform accelerates and streamlines the deployment of Red Hat OpenStack over cloud with fully integrated Big Cloud Fabric for physical fabric automation. In the second part of the demo, I'll walk you through the tenant duplication deployment workflow on Red Hat OpenStack platform using the use case where tenant wants to deploy 3-tier app with web, app, and DB tier. As tenant deploys this application topology on OpenStack, the Big Cloud Fabric creates the logical segment for each of the tier, web, app, and DB using the OpenStack Neutron integration. Before creating application topology on OpenStack, let's look at the BCF controller tenant page and the configuration. As you see, we have 2 tenants currently configured, and we'll create network topology for the tenant RHEL on OpenStack and see how it dynamically provisions the BCF. Let's log in as a RHEL tenant user. As you see, there is no network configuration other than external network created by Cloud Admin for external connectivity. Let's create network for web tier. Provide name, IP subnet, say 10.100.31.0/24. Similarly, create app tier with subnet 10.100.32.0/24. Finally, create DB tier with subnet 10.100.33.0/24. Now let's create the tenant RHEL router to interconnect these 3 application tiers. Add interfaces associated with each of the tiers to the RHEL router. This completes the 3-tier application network topology on OpenStack. Now if you refresh the tenant page view on the BCF controller, it shows the new tenant RHEL created on BCF dynamically. If you click on the RHEL tenant topology view, it shows the 3-tier application topology with web, app, and DB tiers. Configuration view shows the same information as well, web, app, and DB segments under the RHEL tenant. This BCF tenant configuration is dynamically done using OpenStack Neutron ML2 integration. Now let's add instances to each of the tier. Add 3 VMs in web tier. Use web as the network. Similarly, create 3 VMs on app tier and choose app as the network. Similarly, create 3 VMs on DB tier and choose DB as the network. As you see, all the instances are up and running on all 3 tiers. Now switching back to BCF controller and going to BCF controller endpoint page. This page shows endpoint information of all learned endpoints, including the new endpoints we just created on OpenStack. And information includes tenant and segment, its IP and MAC, and the physical server where it is hosted, and the VLAN. That's the demonstration of OpenStack tenant workflow to deploy application and how the integration enables the dynamic provisioning of Big Cloud Fabric to provide self-service model for the OpenStack tenant. In summary, Red Hat Enterprise Linux OpenStack Platform 7 accelerates and streamlines the deployment of the reliable and scalable OpenStack cluster, which is fully integrated with Big Cloud Fabric to enable the dynamic provisioning of the physical fabric. Thank you.
Thanks, Ganapati, for that demo.
We also have a question before we go any further. So this question is actually for Glenn. Does Red Hat have an NSP certification program?
Yeah, actually, we had an OpenStack NFV certification program for some time for storage and networking partners. In fact, Big Switch Networks is one of our first partners to certify on RHEL OSP 7. But what we just announced at OpenStack Summit in Tokyo this week is a formal NFV certification program, and you can go to connect.redhat.com to get more information. We're now able to certify MANO, management orchestration applications or solutions, and we're also able to certify virtualized network function solutions.
That concludes our presentation for today. But if something we discussed here piqued your interest or you'd like to know more, just head on over to our website, bigswitch.com. All of our past webinars, including this one, will be posted online, and you can get to those by clicking one of the green buttons on the home page. Join us on Wednesday, November 11th for our next webinar, Dock Container Networking with BCF. If you want to try out Big Tap Monitoring or Big Cloud Fabric for real, please sign up to get free access to our online labs and get almost immediate access to our products. And last, but certainly not the least, we've launched Big Tap and BCF starter kits. Starting at a list price of $29,000 and $39,000 respectively, these kits include the switching hardware, software, support, and cables that make it real easy for you to implement your very first SDN-style data center pod. If you need more information on that, we have a detailed brochure online. Thank you for joining us. This concludes today's event.